Find all angles to the nearest tenth and sides to the nearest hundredth. Given angle B is 36 degrees, A is 10, little b is 8. So when we're doing this, we are drawing our triangle. I just drew some generic triangle. It's not going to be to scale. I personally like to have my angle here at the bottom left. So this is going to be 36 degrees, and once I've done that, that determines this side opposite is 8, and then I want capital A to be at the bottom because I want the 10 to be adjacent to the 36. So since you've already looked at the previous video about the SSA, the first thing we want to do is find the height. Our height is going to be 10 sine of 36 degrees. Now, if you're not sure where that comes from, you could set up our triangle and say we have sine 36 equals h over 10, solve for h, and that is 10 sine 36. Let's do the calculation. Now, what do we have to make sure? That we are in the proper mode. And since this is degrees, I'll go and change it to degrees. And I'll type in 10 sine 36. And that gives me 5.88 approximately. See that? There, that's a little better. So this is approximately equal to 5.88. What does that mean? That means the side opposite the angle is longer than the height, so it will definitely swing around, and it hits, this will end up being little c, and this is capital C. It'll hit little c somewhere over here on the right. When it swings around, since 8 is less than 10, it will also form a second triangle over here. So 5.88 is less than 8, and 8 is less than 10, so therefore 2 triangles are formed. That means we need to solve for both of those triangles. The first thing to do would be to find angle A. Why? Because I can use the law of sines. The sine of angle A over 10 equals the sine of 36 over 8. So that will give us sine of A equals 10 sine of 36 over 8. Take out your calculators and type that in. 10 sine 36 divided by 8. And that gives us 0.73, approximately 0.73. Now when I'm looking at my unit circle, this is a positive value. We have 2 answers to that. We have sine A equals, so A will be the inverse sine of 0.73. So on our calculator, we can just hit inverse sine, so second sine, and then second the negative symbol, so answer. Let's see, make sure you can see the screen there. And then hit enter, and it gives me 47.28 degrees. Now let's store this right now into alpha A. Remember in one of the previous videos I went over on how to store things. Let me take this off and see if I can get the screen to show up. Not really. Let me zoom it out a little bit because I want to show you where those keys are again. So the stow key is stored right above the on key. So I would hit STO, and you can see there very lightly, and there's nothing I can do about that one. It says answer, and I want to store it into A since that's the variable I'm dealing with. So I will press alpha, and then the A key is right below it. It says math on it, and I hit enter. Now whenever I need that angle, it's going to be stored there. So then how do I get the other angle? I can write this down. Approximately 47.28 degrees. Oh, we're going to be going to the nearest tenth, so let's change that to 47.3 degrees. Or 180 minus 47.3 degrees. And on our calculator, you could say 180 minus second answer. Hit enter, and we're going to need a place for this as well. I typically use the letter right under A for it because it is A also, but it's in a different triangle. So hit the STO button again and say alpha D. You can choose any letter you like though. So we have 132.7 degrees. And we're going to keep all those decimals until the end. So let's take a look at what this triangle looks like. This first triangle is really the one that we were given, or the one I drew. It looks something like, let me redo that. Slip of the hand. It's okay. Okay. So we have this given angle is 36 degrees. We know this is 47.3 degrees. This is 8, 10. We have capital C, B, A, and then little c. The next angle to find would be angle C. So we know that angle C is going to equal 180 minus 36 minus 47.3 degrees. Now I probably should just go ahead and draw this one at the same time so you can see it. And I'm drawing this one a little bit exaggerated, but this is 10, 8, and this angle is 132.7 degrees, and we have 36 degrees, and all the sides are labeled in the same way. Let's put a dotted line over here, and we can say angle C in this case would be 180 minus 36 minus 47, not 47 in this case, it's minus 132.7 degrees. In fact, it's probably easier for us to do this second column right now and then go back and do the first, because the last number we have on our calculator is this 132.7. So let's see on our calculator, and I can cover up that part, that doesn't matter. We'll do 180 minus 36 minus second answer, or I also could use alpha D, and that gives me approximately 11.3 degrees. Let's store this just in case. Hit STO, and we could store it either in C or we could store it in F, just to be on the same line as the D. I'm going to do this consistently there, so I'm going to put it in F. And we could also put a little bubble, a thought bubble here, and just say F. So if we forget it later on in the problem, we can go back and say, okay, that's right, it was in stored in F. So now I have angle C, and the last thing to find would be little c, and we have the law of sines again. Now remember, if two fractions are equal, their reciprocals are equal. So what does that mean for the law of sines? That means I could also flip the law of sines. So instead of saying sine A over little a and sine of B over little b and sine of C over little c, I can say little a over the sine of angle A, little b over the sine of angle B, and little c over the sine of angle C. So I can say C over the sine of 11.3. Now I have a choice for which side to use. Do I want to use A or B? Well, I really don't want to use A, because I had to calculate that one and I'm going to have to use that value, the stored value. It would be better for me to use B because that's a fixed number and we know it's guaranteed. There's definitely no error in that. So we can say little c equals 8 sine of 11.3 over the sine of 36. Now, let's see, we'll type 8 sine, well, we have this 11.3 was our previous number, so we can just say answer divided by the sine of 36. We hit enter and we get an approximation of 2.66. Now let's come back. And so that says this piece there is 2.66. We've solved this triangle. We have all the pieces of information. That triangle's done. Let's go back to our original, our first one. And maybe it'd be better if I slide this one over, at least so I can see that calculator screen still. Yeah, there's better. Where did we put 47.3? That was in angle A, so we want 180 minus 36 minus alpha A. And we get 96.7 degrees. And similarly to the other triangle that we just solved, we can say little c over the sine of 96.7 equals 8 over the sine of 36. Notice that's very similar. So we have 8 sine of 96.7 divided by the sine of 36. Type that in our calculator. 8 sine of answer again divided by the sine of 36. And we get C is approximately equal to 13.52. And we don't have units, so we'll just leave it as that. And there is an example of solving a problem given two sides and an angle not included. That's where two triangles are formed, and we have to find all the information. We have to find A, B, C for the angles, and little a, little b, little c for the sides. We've done that, we have it all, and we're done.